In this example, what we're going to do is we're going to maximize the volume of a right circular cone that is circumscribed inside of a sphere with a radius of 3. So, first of all, let me just remind you that a right circular cone would have like a circular base, right? And it would be a certain height. So this would be like the height, and this would be the radius of the cone. And the volume of that cone is 1/3 pi r squared times the height. So this would give you the volume of the cone, but now this cone is inside of a sphere with a radius of 3. I don't know if how well I can draw this, but you know, you have a sphere. The radius is equal to 3, and I don't know, so you have this cone, right, that has a certain height, and then this would be kind of a cross section, I guess, and this would be the radius of this cone, and then you'd want it to go to the top of the sphere. Okay, and but this circle, this thing is going to be, it's kind of hard to draw this, but this is going to be kind of like, the radius here is going to be kind of like in a circle. So let me show you what it would look like on the side. I'm trying to draw a three-dimensional picture. So you have this, you know, circle with a radius of 3, and this is like a sphere, kind of a cross section. And then you have a cone, and it's going to look kind of like this. Oops. And the radius here is going to be this distance, right? And then you have this cone here. And the height is going to be all of this. This is like the height, right? And so the volume of this would be this radius, so it'd be 1/3 pi times this radius squared times this height. Okay, so now how are we going to do this? We want to get all of this in terms of one variable, and so what I'm going to do is I'm going to think about this being a circle centered at the origin. Okay, so this distance from like here to here is equal to 3. Okay, and this from here to here is equal to y. Okay, because what I'm going to do is we're going to let y go from 0 down to, I guess, 0 down to 3, or it would be like 0 down to -3, but it works either way. So don't worry about that. I don't want to confuse you, but I'm going to say that the height is equal to 3 plus whatever that y is. Okay, so that's going to be the height of your cone. Now this radius here, we have this point x, y, and it's on this circle. So this cross section is a circle where you have x squared plus y squared is equal to 3 squared. Okay. And so what I want is r here, but this r is the x, right? So I'm going to solve this thing for y. I'm going to get everything in terms of y. And so if I solve this thing for x in terms of y, I'm going to get, I'll write it over here. X squared plus y squared is equal to 9. So you're going to get x squared is equal to 9 minus y squared. And then x is like plus or minus the square root of 9 minus y squared. So you would get a positive here, and you could get a negative over here. This would be the positive, that would be the negative, and we're going to take the positive one. Okay, so my radius here is going to be just that x, which is the square root of 9 minus y squared. So this is my height and this is my radius, and what I'm going to do is I'm going to plug these into this volume formula to get a volume, and the volume is going to all be in terms of y. So I get 1/3 pi, and then I have this, which is the square root of 9 minus y squared, that quantity squared, times my height, which is 3 plus y. So it would look like that. And now we can simplify this. So this is like pi over 3, and then this thing, this is the square root squared, so that'll just be 9 minus y squared, and this will be 3 plus y. And so that's nice, because now we just have a polynomial. So I'm going to write pi over 3, and then I'm going to multiply these together. So this first two would be 27. FOIL outer 2 would be 9y. Inner 2 would be negative 3y squared, and last 2 would be negative y cubed. And so it would look like this. And notice all of these, none of these combine. So we're just going to leave it like that, and I'm going to take the derivative of this whole thing. And hopefully it'll be something we can take the derivative of. So dv dy. And I'll have the pi over 3, and the so I'm pulling out the constant multiple and taking the derivative of each term, so that'll just go away. This will just become 9. This will be minus 6y, and this will be minus 3y squared. And so I'm going to get this. And so now I'm going to set this equal to 0. So imagine doing that. Then I can get rid of the pi over 3. Okay? And because I can divide both sides by that. And then I'm going to commute these around. I'd get like negative 3y squared minus 6y plus 9 is equal to 0. So this will be equal to 0 when this is equal to 0. And now I can pull out a negative 3 as well. And then I got y squared plus 2y minus 3 is equal to 0. So then you can divide both sides by the negative 3 and get rid of that. And then this thing, I think I can factor. So I'd get y, and it'll be a plus and a minus because that's a minus. And I want a 2y, so it'll be y, positive 2y, so it'd be y plus 3 times y minus 1 is equal to 0. Then if you multiply this together, you get that. So you get y is equal to negative 3, and then y is equal to positive 1. And as far as the constraints here, we're going to say y equals 1 is the only one that's going to make sense here, because this would bring it all the way down to here, in which case you wouldn't have any radius. You would get a 0 here. So we're going to say that this is the only critical point. And now what I want to make sure is that this critical point is going to give it, is going to make this volume, which is this, it's going to make that a max. So what I'm going to do is I'm going to take the second derivative here of this and then make sure that that is a negative. If the second derivative is negative at 1, then it'll be concave down, it'll be a max. So d squared v over dy squared is going to be pi over 3, and then that'll go away, and then you're left with negative 6 minus 6y, and certainly if you put 1 in there, this is going to be less than 0, making that a max. So y equals 1 is a relative max. Okay, and you can't include 0 or 3. It's going to be between 0 and 3. And so we're going to say that that is the relative max. And in that case, the height, so the actual dimensions, the height would equal 3 plus 1, which is 4. The radius would be 9 minus 1 squared, which is equal to the square root of 8. And that is, whatever it is, approximately something a little less than 3, right? Square root of 8. So 2.83 approximately. So these are going to be the dimensions of a circular cone that can be inscribed in the sphere that has a maximum volume. Okay? So, very good. Let's see, we'll probably try a few more examples here.